91 forecast for unpowered flights. Go ahead, Tony.
Thanks. Can everybody hear me? Yep. Great. Glad to be here. Excited to talk to you guys all today. A little bit about myself. I'm an ATP power pilot, multi-engine pilot. I've been flying gliders since I was in college. Not a trained meteorologist. I'm an amateur meteorologist. Everything I've learned about weather has been as a necessity in order to be successful in my job as a charter pilot or in soaring flight. I'm president of a local soaring club, the Kansas Soaring Association, based out at south of Hutchinson, Kansas at Sunflower. I've been lucky enough recently to compete twice on the U.S. soaring team in 2015 and 2017. So in 2015, I flew World Championships in Lithuania, and in 2017 we were in Hungary. That was a really interesting experience. I've been able to do quite a lot of flying in gliders around Kansas, which has allowed me to set several state distance records, speed records, and also one U.S. national record. I was the meteorologist for the U.S. National Sports Class Championships in 2014 and Pan American Championships in 2015. Of course, focused exclusively on soaring weather and a couple regional contests. Part of flying a glider is kind of a battle of wits between you and the weather. So I consider myself to be an avid weather observer as a result of my flying experience. I'm curious who in the room has ever flown in a glider. I know we got quite a few club members, but anybody who's taken a ride or anything like that? A third, maybe a half. Cool. This is my personal glider. I own half of this glider, but luckily my partner lets me fly his half every now and then. This is Schimper Standard Series. It's state of the art in 1971. It's a 15-meter glider. It's fiberglass construction. Glide ratio on this glider is about 36 to 1, so a little bit better than a Cessna with the engine out. One thing about a glider, we get towed up to start the flight, right? Usually get up to a couple thousand feet by however we launch. This aircraft is going to be descending through the air at about 200 feet a minute all the time, which means unless we can find some rising air, we're going to be on the ground 10 minutes after I let go of that tow plane. 2,000 foot tow, 200 foot a minute descent. So the real challenge for me for soaring flight and for most glider pilots is to figure out where to find some air that's going up at least 200 feet a minute. You extend the duration of flight, you gain some altitude, you can convert that into distance. On a good enough day, you can push harder and try to see how fast you can go around a course, and pretty soon you've turned this into a sport and competition. As a result, you become very interested in learning a lot about a very specialized field of micrometeorology. 200 feet a minute is 2 knots of wind speed, right? That's a barely perceptible breeze, especially in Wichita. But that's all we need in a vertical component to be able to sustain flight, to sustain our altitude. So, so as a result of that, we're learning a lot and thinking a lot about how there's these very subtle currents in the air and how we can take advantage of that. So 3 kind of classical types of lift for soaring flight: thermals, ridge, and wave. And so I'll spend most of my talk talking about forecasting thermal conditions because that's what we have here in Kansas. Then there's some other interesting phenomenons that I'll touch on at the end and hopefully have some time for questions. First, a little bit of visualization. You can't see the air, right? So what does this thermal look like? So I've got 3 examples of rising bubbles here. Hot air balloon is something that Jay mentioned in his talk this morning. It's a heated mass of air. That air is hot, it's less dense than the air outside of the balloon. As long as that remains the case, that hot air balloon is going to rise. It has its own heating source. It carries along a big tank of propane, right? And the thermal is a rising bubble or a column of air in the atmosphere. As long as that bubble is hotter than the air around it, it's going to continue to rise. And so our interest as a soaring pilot is how fast is it going to rise and how high is it going to go. The boiling water in the bottom right is probably one of the best visualizations for really what happens in the lower atmosphere as thermal generate, because you have a surface heating going on underneath the fluid, which is the lower part of the atmosphere. Another great visualization of thermals is in dry, dusty climates where the thermals actually pick up dust. Dust devils are just thermals with some dust particles thrown in, so you can actually see the organization, and it's like smoke in a wind tunnel. It's a beautiful thing. We love them. It's exciting. When you see a dust devil, you know there's a thermal there. There's no better feeling in the world when you're flying a glider to actually know there's a thermal somewhere. Most of what we do is kind of reading the sky and a little bit of feeling the air and throw in a little dash of experience, but there's still an element of hope of some sort. You know, it might only be 5% or 10%, but to really know something is a wonderful thing. That picture on the right, I believe, is from Africa. This is an incredible, tightly wound thermal, nice solid core. And what I thought was interesting on that picture is you can see how the wind, either speed or velocity, speed or direction or both, shifts with altitude. And so thermals do the same thing. They wind up. They're not just this straight up column. Beautiful cumulus at the top of those as well. Bottom left, I think, is somewhere in Arizona. And does anyone recognize the picture on top left? Yeah, there's actually two dust devils in there. There's another one on the small one on the right side. That's on the surface of Mars. I think that was from the Opportunity rover. One of the rovers got this picture a couple years ago, and glider pilots everywhere just lost their minds when they saw it. There are thermals on the surface of Mars, and we just got to get a tow there. There are gliders flying now that are capable of generating lift at the Reynolds numbers you would see in the very thin atmosphere of Mars. So just got to figure out how to get there. That's pretty cool. That's exciting. So a little bit of background basic on the process of what happens here. Sun comes up in the morning, heat starts to heat the ground, right? As soon as it hits the ground. That ground warms up, and it warms the cushion of air right next to it at the surface. Something triggers, or maybe a little gust of wind or a little variation in the terrain or something triggers that bubble to release and to start to climb. And then there's a little bit of kind of a PV equals nRT kind of thing, so that's kind of a closed system, but same kind of thing happens as that bubble rises, it expands. As it expands, it cools. As long as it stays warmer than the surrounding air, it continues to rise. And it will continue to rise until the temperature of that bubble has cooled down to equal the temperature of the surrounding air. So it's like a real basic, simple concept to keep in mind as we get a little more complicated. The key thing to remember is that rate of cooling, 3 degrees Celsius per 1,000 feet. That's what you'll hear called the dry adiabatic lapse rate. If you get into the SQT charts that Jay had this morning and that kind of thing, you can get easily down into the weeds. Just remember a thermal rising cools at 3 degrees Celsius, 5.4 Fahrenheit for every 1,000 feet it rises. So, and here's a little picture I found online at about 10:30 last night to kind of show that. You have the surface air is heated 32 Celsius. That's a pretty good summer day. It's about 90 degrees. This is in meters, 10 degrees Celsius per 1,000 meters, 3 degrees per 1,000 feet, same thing. 22 Celsius at 1,000 meters, 2 Celsius at 3,000 meters. Where in the case of this photo, that air is now cooled to the dew point in the cloud forms. So two pieces of information we need to have to make a thermal forecast. The surface temperature, which is usually actually not that hard to figure out. Pretty good thermometers available, with the exception of this last week. Usually the forecast high for the day is pretty reliable, within a degree or two. So pretty easy, pretty good forecasting available for a high temperature for the day. Pretty easy to just pull a thermometer out of your pocket and figure out what the temperature is. More difficult is the temperature aloft. Because we take that forecast high for the day, we know it's going to be X degrees. We know, okay, well, in order for that, if that piece of air is going to rise to 3,000, 5,000 feet off the ground, it'll cool to this temperature. We need to know what the temperature at that altitude is already. So direct measurement is one way to do that. It's not super easy. At our regional contest we had last summer, we just put a thermometer on the wing of the tow plane and climbed up 6,000 feet every morning. This is about the only way to get a really good direct measurement of the actual temperature of the air in the morning. Actually worked out pretty good. So we kind of did our own local sounding. Weather Service sends balloons up every morning, but there's one in Dodge City, and there's one in Topeka. And we're in Hutchinson. And with the way the weather pattern's set up, the dry line especially, usually Dodge City is in a totally different air mass than we are, and often Topeka is as well. So that's not super useful information for us.
Tony, we feel your pain.
Yeah, I know.
I wish we had a balloon
Yeah.
launching here in Wichita.
Yeah. I wish we had one launching at Sunflower. So, but basically we get to the point tonight or something. John and Casey were chasing after me with the trailer. They had left Wichita at 8:30 in the morning out ahead of me, and they were waiting for me to get in. When I flew over, I saw them down there, they were ready to catch my wing. Pretty awesome effort on the part of everybody. Brian towed us that day, so it was a cool team effort. Huge flight that day. That was using this spring cold front phenomenon and doing a straight out flight like that, just using the wind to help push it. That was my second flight over 500 miles. I had two others over 400 miles doing that style of flying. So in the springtime like this, we get these incredible days with strong winds. So, the only real practical way to get any big distance is to just go straight with the wind. Fighting into a 30-knot wind is pretty challenging. So the alternative is in the middle of the summer when we can get a little bit of a cool front or something that kind of breaks that inversion. Still keep the super hot temperatures, 100 degrees or something, but break up that inversion with some kind of outflow or some cold front. Then we have the advantage of a really long day, lots of sunlight. And so even if the day doesn't start super early, it can still go late, and you can get a really great soaring day that way.
Tony,
Yeah, go ahead.
It sounded like you were pretty confident that you were going that far that day.
Yeah.
How is it that you can make that kind of decision? That
Yeah.
Still being that far.
So the nice thing in that specific weather setup with the post-frontal cold front flights, I've spent all spring looking at 7-day prog chart, and the 7-day prog chart is really actually pretty good for that. A big cold front passage is a large scale weather phenomenon. Even 7 days out, they usually say within 6 or 8 hours of getting that right. Definitely within 12 hours of getting it right at 7-day time out. So in that case, you have days of planning available. It's not like you wake up that morning and realize, oh, pieces have all come together and you have to scramble. So, I'm able to say, hey, Thursday's the day. I call my buddies that drive in, find a co-pilot, find a crew. We got days to get it all worked out. In that case, yeah.
Can you do it to be that far? Just the front moves down?
Yeah, so the front has to come through and it has to be fast enough moving to get out over the Gulf of Mexico by the next day. If it's slow moving, it stalls out in Dallas, which is pretty common too. We can go, but once you hit the front, you're out of the weather, and that's as far as you're going to go. So, we get between 0 and 7 of these days every spring, and
but the last 5 years or so, John and Casey and I and a few other guys in the club have really been watching and doing our best. Up until this last year, I was just like working as a contract flight instructor and had a pretty easy work life to accommodate this kind of thing. So like if I wanted to just blast off on a Wednesday and fly to Texas and then drive back on Thursday, I could do it. So it's a little more restricted work life right now. But
So how long did it take for that? 7.5 hours flight.
yeah. So a little bit about forecasting. So the idea of taking the surface temperature and knowing what the temperature aloft is over the airport is great. But like Jay was talking about the buff kit, that's just a forecast for one point. And unless you're just planning on flying over top of the airport all day, you need more information. You want to know, is it going to be better to the southwest, to the northwest, to the northeast, whatever. In gliders, we're not trying to go to a flight breakfast or fly home to see our family. So we kind of get to choose which part of the air we want to try to fly in that day. So the nice thing is there's probably about 4 commercial forecasting services that offer soaring forecasts for large areas. This is one called Top Media. It's they're based in Europe. There's another one that has just started in the last few years called SkySight. It's a guy based in Australia. Basically what they're taking is all these forecast model ensembles, grading it up, interpolating between. They take feedback from local soaring clubs to kind of tweak their forecast models, and then they can spit out this huge graph that says, okay, and this particular graph is from last June. I ended up flying about 200 miles this day. It wasn't as good as the forecast, but it's forecasting how far you could fly in a day over certain areas. So this area of yellow corresponds to between 700 and 800 kilometers in distance. The forecast is saying if you fly in this area, say between Amarillo and Oklahoma City, if you use up the entire day, take off at the first thermal land at the end of the day, you should be able to fly 700 to 800 kilometers. So that's what the model is showing. Of course, it assumes a certain level of performance in the glider. The nice thing about these graphical forecasts for soaring is you just pull it up in the morning. You've got a beautiful graphical display, nice pictures, pretty colors to say, okay, today is a day to fly southwest, or today is a day to fly. Today is, say, for example, we have a rare day where the soaring is actually better to the east. So, okay, maybe today is the day to do the lap around Wichita. We only get to do once a year. So this takes a lot of the work out of forecasting. It's important, I think, of course, to have an understanding of what's going into the forecast and how the models work. But this speeds the process up majorly, because what happens is you wake up at 7 in the morning, you got a 45-minute drive to the airport, you have to put the glider together, get ready to launch, and you want to be in the air by noon. So practice in the morning for getting ready for a cross-country soaring flight. You really only got about an hour to look at the weather. And as Jay said this morning, you can always, with 4 commercial services available, all using different forecast models and tweaking them all their own way, if you really want to go a particular direction, it's really easy to find a forecast and tell you that's a good way to go. There's plenty of variability there. So you kind of have to learn, and with experience you learn to filter out what's good and bad. One product that's freely available to everybody to use, and actually is a really good basic soaring forecast, is on the hourly forecast that you get from the Weather Service. If you click weather.gov, Wichita, Kansas, and in the bottom right you can pull up this graph like here. And if you click up here to mixing height, underneath the fire weather tab, it's available from the Wichita office. You get this videogram down here that shows, okay, down here, this is at night, and here you have the day heating up, and as the day heats up, the mixing height rises. The mixing height is that thermal height. And so this is real handy for us glider pilots to get at least a good impression of what the shape of the day is going to be. Is it going to start early? Is it going to start late? Is it going to end early or taper off? But for power flying, when we're talking about the height of the thermals, If you're flying on 172 or something, that's the height of the turbulence, right? That's where you don't want to be. You want to give your passengers and yourself a smooth ride. And so this is going to give you a nice, easy, quick glance at like, okay, the thermals are going to go to 5,000 feet today. So I'm going to plan to climb to 7,000 feet for my cross country, right? Note that this height is above ground. So, but I actually, for our regional contest this year, we used this quite a bit. We took our own soundings to 6,000 feet of the tow plane, plotted out and then with the hourly temperature forecast and mixing height here, we had a pretty good idea of how the day was going to go every day. Worked out pretty good. Right. Another little thermal related phenomenon. So when there's wind, the thermals tend to organize with the wind. And we get this cloud streak phenomenon. Picture on the right is another picture I took when I was in Australia last month. To a glider, I mean this is heaven right here. There's a thermal, there's a thermal, there's a thermal, there's a thermal. There's all the way into as far as you can see is a row of nothing but updraft. That means you don't have to stop and circle. You just fly straight and gain altitude as you go. Super fast way to cover some ground, and just an incredible feeling to not have to stop. You can just cruise along and climb. You average say 200, 300 foot a minute climb as you're cruising straight at 60 or 70 knots. Pretty nice. I mean that's Cessna 150. Not bad. So this picture I took last Sunday. I was flying out to Liberal about noon, and there was a good wind out of the north, and the cumulus layer, it had been a solid layer in the morning, and started to break up, and it was breaking up into rows. Some streeting action going on. Yeah, I was cruising a twin-engine motor glider that I fly for work. Yeah, no, it wasn't that good a lift. So a few things to point out. There's nothing but lift in this line underneath the clouds, nothing but rising air, which means that over here in the blue on either side, there's nothing but sink. And so if you're flying, just something a little tip for you as a power pilot to kind of learn a little bit about reading the sky. Say you're flying from left to right across that picture. When you're going across the blue, you're probably going to lose some altitude, or you're going to have to slow down to maintain altitude. And then as you come underneath this cloud, you're going to get into that updraft, and now you're going to have to speed up to hold altitude. And so next time you see that, you'll know, oh, that's what that is. There's lift underneath those clouds, sink underneath the blue, and you'll kind of get a little better understanding of what's happening in the atmosphere that's affecting your flight. So that's little basics about thermal. Okay, this is pretty much exclusively what we fly here in Kansas. So briefly about ridge lift. Ridge lift is a pretty simple mechanism. The wind. Now, if we had a ridge in Kansas, we would have world-class ridge soaring because we have all the wind we need. We just need a hill. So, this is a picture. Southeast Oklahoma is the closest area for ridge and wave soaring to us. The area down around Mena, Arkansas, and to the west from there. This is a picture I took flying my glider on the Buffalo Mountain near Tallahassee, Oklahoma. This is a 5-mile long ridge. Wind comes out of south. They fly hang gliders and paragliders off this. They've been flying hang gliders off there since the 70s. Super easy ridge to run, great for a beginner. It's like 4 miles from the airport, so it's really low stress. On the other side of the valley is about a 30-mile long ridge, Aviation Ridge, so that works in a north wind. This represents pretty much my entire experience with ridge soaring, so I'm not a real expert at that, but my observation is, say minimum 10, really probably 15 knots of wind needed to sustain an altitude in the glider, just especially to safely to have some extra speed. The stronger the updraft, of course, the faster the glider you go. You want to have some margin above stall speed, of course. Ridge soaring in the U.S. really, for big long distance flights, probably peaked, I'd say, in like the 80s, with big cold front systems that would hit the Appalachians in the East Coast, in the eastern part of the U.S. And pilots would fly from Pennsylvania south along the ridge system, basically down to the southern end of the ridge system and back. Lots of out-return records set, speed, all kinds of speed records, and some distance records. The longest straight line flight I know was a flight that started in Pennsylvania, probably at sunrise, and ended in Selma, Alabama. At the end of the day, just straight out. That was like an 800-mile flight. So minimum wind speed, I'd say 10 to 15 knots at least. Depends, of course, on the shape of the hill. One note I made was, now there are places in Kansas where paragliders and hang gliders can do some ridge swimming, particularly up in northern Kansas. The dam at Wilson Lake used to be a really popular place until the cops told the hang glider guys they couldn't jump off the road anymore. There's still a few hills up there in northern Kansas where hang gliders and paragliders will do a little ridge swimming. And I noted, you guys all knew about the Spaceship Two flight recently. They finally got into space. And Mark Stuckey was the pilot on that aircraft. And he started flying. He went to K-State in Manhattan, and he started flying hang gliders in Argentina. That's how he got started in aviation. And now he's an astronaut. He just got his wings yesterday. So. A few slides on mountain waves. So kind of typical textbook diagram of mountain wave here on this side, and then if you're taking the glider pilot knowledge exam anytime soon, this is what you need to know for how a mountain wave forms. So you need 20 knots of wind perpendicular to the ridge line. So if the wind is off perpendicular, then it needs to be stronger than 20 knots. But you need a 20 knot component across the ridge line. So thermal lift is based on an unstable atmosphere. Ridge or mountain wave exists in a stable atmosphere. So you need stable air at ridgetop height, and then an increasing wind speed with altitude. So say the wind is 20 knots at ridgetop height, 30 knots, 40, 50, 60, increasing speed as you go up. And in this picture, pay no attention to anything left of the peak of the mountain. It doesn't matter on the formation of mountain wave. What matters for a mountain wave to form is what happens downstream of the mountain. And so the wind is blowing along here. It's kind of like, there's like some stored energy in the height of the atmosphere of that air. And when the wind drops off the side of the mountain, it's like stretching out a spring. Okay? And so then it bounces back. And it depends on the temperature profile and the wind speed profile as far as how strongly it bounces back. But as long as the air here is stable, if stable air wants to stay at that level, it's being forced down because the terrain drops off, and so it springs back to want to be at that level. And of course, it overshoots a little bit, and so then, and depending on the harmonics and the temperature profile and all kinds of stuff that I don't really truly understand, depends on how many waves there are downstream. And if you look at the satellite pictures, I mean, you'll see days where there's bars of clouds parallel to the Rocky Mountain range that extend all the way across the state of Colorado and into western Kansas. So some days there's just all kinds of harmonics that line up. Of course, in the glider, we're interested in being in the part of that wave that is going up. In your textbooks, in your airplane flying textbooks, they spend a lot of time talking about the danger of the mountain wave as far as the strong downdrafts on the downwind side of the mountain and the turbulent rotor clouds at the bottom. Okay? But what they don't mention in the power books is when you get above that rotor cloud, all of this air is laminar flow. It's perfectly smooth. It's the absolute smoothest air you will ever fly. There's not even vibration. It's magical. And so you get up above that, you're in smooth air, and you position the glider to stay in that rising current of air. You can do that by reading these clouds that form at the crest of the wave. You want to stay on the upwind side of them, and you can ride that up to however high the wave goes. Wave is capped. Wave will always be capped if there's a temperature inversion or a shift in wind speed. We have experience with, down there in southeast Oklahoma, there have been a few wave flights. And November 2 years ago, two of us got over 20,000 feet down there, which, if you guys, I don't know if you guys have ever been down, but we're talking about a ridge that is 1,500 foot high. The highest part of the Kiamichi Ridge is about 2,000 feet above sea level. And the surface, the valley is about 500 or 600 feet. So a tiny little bump in the ground. But in this day, the wind was strong out of southwest, blowing across the ridge. The speed profile was about constant with altitude, but it looked good. And I was flying this glider that I'm in. I borrowed from a friend. It's a self-launching electric motor glider. So I took off, didn't need tow plane or anything. Took off at 8:30 in the morning. Started climbing real slow, 150 feet a minute. Just a really slow, steady climb. Got a hold of Kansas City Center, got a transponder on board, got flight following established. As I got to about 16,000 feet, started to negotiate for a clearance above 18,000. Once I had mentioned to them that I was an IFR rated pilot, they granted that, and I got a clearance to 20,000 feet, which was enough to keep my diamond altitude gain 5,000 meters, and to set the Oklahoma State altitude record. And that was fine. I mean, that was more than enough for me. Got to 20,000 feet at about 10:45, pulled the boards out, landed about 11:30. But the whole climb was about 150 feet. It was really weak. But I do mention this because it's easy for us to, as power pilots, to look at the hills down in that part of the country and think not much of them because they're pretty small. But they do kick off the same phenomena that we see out in the big mountains in the west, just to a smaller degree. The rotor here, I did fly through some of the rotor that day. It was not particularly turbulent, but it was definitely there. But the ridges definitely do cause updrafts and downdrafts in that part of the country.
Did you have to circle to stay in that?
No, so it's hard to see. No, so circling, in this case, the wave is anchored to the ground. So it's a stationary wave. So you want to fly a ground trass, a steady ground track in this case. It's hard to see, but on my moving map here, you can see all these lines up and down. So I had the GPS laying a crumb trail, and it's actually color coded to be bright colors when I was climbing and dark colors when I was descending. So after a few passes back and forth, I could actually see on my GPS like where the best part of the lift was and where the worst part was. And so I was just tacking back and forth to stay over a particular spot. And I was working in a zone about 2 miles, 3 miles wide there, just a really narrow little ripple in the air. Most exciting thing going on at Soaring right now worldwide is the Berlin project. And this photo was taken last September. How high do you suppose those guys are there?
72,000.
Yeah. Notice how dark the sky is. This is not Photoshopped here. This is a photo from their tailwind camera. These guys last September reset their own world altitude record 3 times, and the highest altitude was a pressure altitude of 76,000 feet. This is in a wave system that it's an interaction between the lower altitude wave over the Andes Mountains at the southern tip of South America, and the interaction between that lower level wave and the polar vortex, the real polar vortex around South America, that sets up a stratospheric wave. And that wave has been observed up to altitudes of 100,000 feet. This aircraft is designed to fly at 90,000 feet. And they bumped the record up last season from like 53,000 feet to 76,000 feet. Incredibly exciting stuff. This aircraft, I mentioned, the density of the Earth's atmosphere at 90,000 feet is about the same as the density of the Martian atmosphere. So back to my dust devil on Mars. If we can get the Perlan there, it should be able to work a little.
So how fast was he going?
So there's all kinds of really interesting scientific problems with this kind of flying. Life support is a big one. It's a 2-pilot pressurized cabin. Pressurized the same way Spaceship One is, a sealed cockpit. Aerodynamics is huge. Their true airspeed at this altitude is like over 300 knots. So they start to run into the high altitude coffin corner kind of problems between stall and flutter. And so you've got major aerodynamic problems, really high-tech meteorology, really high-tech life support, super crazy stuff going on. This last season, what enabled them to help break this record this last season is they got a turboprop tow plane. so they could just tow to 40,000 feet to get started. I mean, no kidding. It's got a 900 horsepower Garrett turboprop. It's an aircraft that was built by Grove in the 80s. 100-foot wingspan, pressurized tow plane. So, anyways, pretty cool stuff, pretty exciting. And so they broke the U2's official record, right, Michael? I think they broke the official record the U2 had, and they still have a few thousand feet to break the SR-71's official record. And when they do that, they'll be the highest official manned aircraft ever flown. A few other quick ones, I'll take a question or two maybe, and then we'll wrap it up. So some oddball stuff. A lot of interesting things that happen in the atmosphere that will cause a 2-mile-an-hour vertical wind. And this one we call it obstruction wave, but basically it's a wave interface with cumulus clouds. Typically happens on days where you have pretty tall cumulus clouds. Notice the top of that cloud, how it has there's a cap cloud or a lenticular cloud on the top of it. So what's happening, and you can see how it's leaned to the right here. The wind is moving from left to right, and the wind speed above the cloud base height is pretty strong and increasing. So this was a great soaring day. This is like a 10,000-foot day. The air is moving up the side of this cloud and cresting right there where that lenticular is formed, and then down on this side. So one of our members got to 14,000 feet this day in this kind of obstruction wave on the upwind side of the cloud. Pretty interesting phenomenon. It doesn't happen very often. Pretty tricky to get into. You got to get up to the bottom of the cloud, then out the upwind side, and then connect with this. You got to kind of make that connection between the thermal and the wave above. Another interesting one that I experienced a couple years ago. Every time I look in a book, I see a cross-section picture of a cold front, and it's like instead of the wind blowing against the ridge, it's like the ridge is moving, right? The cold front, it has shaped just like a mountain ridge, except it's moving through the air, right? So that air, that warm air on the other side of the cold front has to be deflected up. And so ever since I've seen that, I thought, boy, it'd be fun to surf one of those. You know, you could potentially fly for hundreds of miles just if you could find the front edge of that cold front and surf it. And on this particular day, I just got lucky, and a guy showed up at the glider club for a ride at the perfect time. And as we took off, I could see some dust getting blown. About 5 miles north of the glider club, I could see that the wind was blowing much stronger there than it was at the club. And quickly decided that the front must be between me and the dust. And this cloud formed above us, and you can see the concave shape of the cloud there. And I was able to fly on the leading edge of that concavity, and it was the altitude difference between the edge here and the peak was over 1,000 feet. And so it was like flying underneath a ridge almost, and it was just steady lift, 100, 200 feet a minute. It was a really unusual phenomenon. It's the only time I've ever seen that and been able to take advantage of it. So, outflow boundaries are really interesting phenomenon as well. Localized effect, usually from a collapsing storm, where that air, as the guys talk about severe weather, talked about earlier, a massive downflow of air in the middle of a storm, it hits the ground, it has to go out, and it forms a little frontal boundary, which then kicks up air ahead of that. There's definitely usable lift there. Great care is required because you're usually then operating near pretty major weather systems. I got this picture, obviously early one morning, flying over northern Kansas in the Barren, and there's this big mesoscale that had built up overnight in Nebraska, and it was falling apart. Yeah, and it's pushing out, and you can see it's forming clouds up here. And so, if only I could have been in a glider down there, I could have explored that a little bit. And the last pretty interesting phenomenon is this undular bore phenomenon, which we talked about in the last seminar. But it's a similar setup where a big storm system collapses, but when the outflow hits the adjacent air mass, it actually kind of sends a ripple upstream. And this happens reliably in the Gulf of Carpentaria in northern Australia. It's called the morning glory cloud. If you Google morning glory cloud,
You'll see all kinds of videos of guys surfing that thing over the Gulf. Sometimes there's guys who take motor gliders out to sea over this thing. You can see it continues out over the water. There's been some really long distance flights done on this. A bunch of hang glider guys have done it. These do happen over Kansas. We've seen it, but we've never had a chance to take advantage of it. So that's the end of my presentation. Andy's giving me a 2-minute warning. So.
We probably have time for about just one question.
Okay, Bob?
Yeah, Tony, you mentioned the word harmonics earlier. I didn't quite follow what that term meant.
Yeah, it's just the sort of spring theory on a mountain wave. So when the air falls off the back of that mountain, depending on the temperature profile, it's kind of like how tightly that spring is sprung, which then says how quick it's going to rebound and how strong the lift is going to be. All right, I've either explained everything perfectly or you're completely confused. Thanks.